grateful to be here today at Paul Sabatier University in Toulouse, attending the Math and Science Congress.
It is a wonderful opportunity to be able to talk about the subject that we all love, maths, in front of such a wonderful audience.
But enough talking, let's get to our problem, which is appropriately named chiffrer. The first time we read it, we thought to ourselves that a computer program would make it easier to solve the problem. And it did.
To better understand the problem, here is the test.
Si n est un entier naturel, on le transforme en un entier grand n en remplaçant chaque chiffre à deux n par le chiffre ou le groupe de deux chiffres deux fois un plus. On peut avoir des situations où le rapport grand n sur n est entier.
If small n is a positive integer, we can transform it into another number, capital N, by replacing each of its digits, a, by the following formula. A becomes 2 times a plus 1. Can capital N be a multiple of small n?
You remember that we said something about the program. Well, here it is. This is the code. And if we press enter, these are all the numbers that follow the rule. These are the first one.
Practically, we here already proven that these numbers do indeed exist.
But as you know, mathematicians always dig deeper into a problem, and they always have a question on their mind, and this question is why.
So if we go back to our project, this is why. So the smallest number we have found is actually 1, which becomes 4. And the biggest number we have found so far is that, and it transformed into this number.
One of the rules that we found is 111 and 222 low. Here in this slide, there are some examples. And now the rule. We chose small n and also capital N, the number in which small n transforms. We saw that if all the digits are 1 or 2, capital N will have the same number of digits as small n. So we write small n capital N in base 10, as you can see. If small n divides capital N, then small n divides 2 times small n plus 111 infinite times. So small n divides this one. Because small n divides 2 times small n, that means that small n divides 2 infinite times. So small n is a number that either has all of its digits equal to 1 or all of its digits equal to 2.
We have also found another law, the 58 law as we called it. If we have an uneven number of groups of 58 that form the number n, then small n divides capital N because 58 transforms into 1218. If we write an infinite number of groups of 58, after some calculus, we can write it under simpler form. Capital N over small n is 21 multiplied by 10 to the power of 2 multiplied to 10 to the power of 2k plus 1 and divided by 101. So if small n divides capital N, only if 101 divides 10 to the power of 2k plus 1. But as we found, 10 to the power of 2k plus 1 is actually a multiple of 101, and we add minus 1 to the power of k plus 1. So we have found out that small n divides capital N if and only if k is an odd number. So any number of groups of 58 will always divide the same number of groups of 1218. If and only if the number of groups is odd. So one group of 58 will divide one group of 1218. Three groups of 58 will divide three groups of 1218. And so on and so forth.
Here are the other numbers that we have found. And we are sure that there are infinitely many numbers that follow one rule or another, and we invite you to try to solve the problem for yourself.
Thank you.
Thank you.